At some point, I ended up with the door, but it had a few problems. Too many people would not close it when they went out, and too many people would keep the key when they left for good. Additionally, if anyone found the key and had the slightest clue on where it belonged, all this made this door pretty much useless as a safety device. One attempt to solve the last problem was to multiply the number of keys in a process called security by obscurity, but that turned out to not be very practical, especially at night. Going full cybernetic came as a less straightforward but still reasonable solution. However, the door was never intended to be handled by a robot of some sort, so there was much to do. This dude is somewhat effective at keeping people out, but teaching him to open the door would have taken a while. So I built a robot around the door. Since the door was already in place, there was no choice but to move the work right there. Luckily, it's not too far from the workshop. First, recycle a linear actuator from an old hospital bed, then make some sort of support for it on the wall and on the door. Due to the very limited space and virtually no choice in the actuator, figuring out the geometry of the system took a while and ended up with trial and error until I was satisfied. I also made no drawing here and everything is mostly eyeballed, so I have to open and close the door frequently to make sure the parts fit together. It's close to minus 10 degrees outside, so I'll try to get this right quickly. Now that it kind of works, I need to pull some electric wires so my tests actually mean something.
Wait for the ramp, Morty. They love the slow ramp. Really gets their dicks hard.
For a number of reasons I will not discuss here, I decided to go for Raspberry Pi as the brains of my door robot. This obviously required me to make some electronic circuit board because of all the end stops and safety switches, just two, the user switches, also two, the RGB light for the challenge response, the door latch and obviously the electric motor as well as some RFID reader, and the fire alarm relay, and maybe something else still. My first attempt was this small board here. Such prototyping is nice on paper and if it works on the first try, but spoiler alert, this was not the case here. It was a while ago, so I don't quite remember what I messed up. I also figured out that if anything went wrong with the circuit and needed to be fixed, I would need a drop-in replacement so that meanwhile the door would keep working. But I didn't want to design a PCB that would work only for this particular door. So I went crazy and designed the Skippy board. It superimposes a number of N and P circuits that can be selected with the help of a few solder jumpers and careful placement of the components. As a consequence, it's basically a 5,970,000 something in one PCB because of all the combinations that can be achieved. A lot can be said about this board, so there's a link to the documentation just here. Even with such a nifty PCB to work with, it took quite a while to solder all the components, and since there are so many possible configurations and it was the first time assembling it, I simultaneously wrote the documentation. I was required to read through tons of datasheets again. For those who don't know what a datasheet is, it's some form of poetry that explains with more or less clarity how electronic components like to be comfortable and how they must be talked to. This form of poetry does not know humor, love, hate or hunger. Therefore, it's mostly boring. Writing the script to manage the door was very tricky too. There are a lot of requirements and I will not go into them in details, but in short the door must work reliably at all times. Working from my office 10 meters away through two closed doors was not cool, as I would sometimes have to rush out to see if things work as expected, or to pull the plug. So I set up an office, just a chair near the door, but with the temperature barely above freezing point this option couldn't last long. I had to take the door next to my desk. But how? And what if I made a record-breaking, smallest full-feature automatic door in the world? With one of the spare PCBs, some leftover wood from another project and a bit of imagination, ta-da! The door hinge is made of masking tape, the motor has no hinges and is just hanging on its wires, but otherwise this teeny tiny door that goes by the name of Alice is an almost exact replica of its larger cousin and shares most of its features. Without Alice door, I may well have lost some fingers to the cold while working on the full-size version. This door uses some cheap RFID tags as a primary method of authentication, because they're cheap and because I had the stuff laying around. It obviously means that it's fairly easy to copy or otherwise spoof the tags, hence gaining access to the infinite marvels and treasures to be found behind this particular door. To be fair, the safest, most expensive, high-end, high encryption RFID tokens turn out to be no better than the crappiest key when they get into the possession of a suspicious individual. To solve this problem, my door can talk to the user and the user can talk back to the door. The door doesn't exactly talk, but it can output Morse code with an outside-facing LED, and the user has a single vandal-proof button to respond. The button can only send short pulses, therefore it cannot readily be used to send Morse code. To make communication easier, the user button is surrounded by an RGB LED ring. After Morsing a short message to the user, the door displays a sequence of colors. The sequence is repeated as many times as necessary for the user to press the button each time the ring is of the desired color. For the sake of the example, you would show your RFID tag, to which door would respond, "What color is the sky?" You would then confirm your identity by pressing the button when its color is blue, because the sky is blue. In practice, the question will be much shorter and abstract, such as just A5, and the answer quite longer, like blue, red, red, yellow. As it turns out, I only sort of reinvented secret door knocks, only this time for computers. Ain't that cool? Final test on the board is that of the H-bridge. This allows me to spin a DC motor in both directions. As satisfying as it is to watch this, there is still a lot to do, so let's move on. There is a lot of tracing and cutting and welding and tracing and cutting and welding and hammering and tracing and cutting and welding and hammering. Also, I did not get the dimensions right on first try, so I need to slightly increase the length of the robot's forearm. Instead of making a new part, I'll just cheat somehow, bend it to a suitable size and lock it in place with some reinforcements welded. I also add this broken shower hose to protect the electric cables that go to the motor and fire safety switch. Perfect. Now that it works, I can paint some bright yellow safety lines on the floor. Thanks for watching, I hope you enjoyed it. Now make your own door, make your own dream. Yeah, whatever. I don't know. Just something. Yeah, do something.